Hello everyone, we are Team Iutcn participating in the SC Ecoconcrete Student Competition 2021. Our team consists of Chowdhury, Zubayer and Zahid, myself, Farhan, and Badhon, Redwan-Ul-Islam, Ehsan Kabir, Shahariar Alam, and Rezwan. And of course, our faculty, advisor, and mentor, Professor Dr. Tarek Uddin. Now, just a brief introduction to our solution. We tried to create eco-friendly concrete to enhance the durability of concrete. And in the process, we created two different mix design. One was for the base case scenario and another one for the alternative case scenario. In the alternative case scenario, we just replaced Portland cement with some SCM and ASCM products to enhance the durability of concrete. And we followed it by a life cycle analysis or assessment in order to identify the environmental impact that the scenarios will have on the environment. Finally, the selected materials were divided into two parts, cementitious and aggregates. In the cementitious part, we had Portland cement for both cases, and then in the alternative case scenario, we replaced some portion of Portland cement by fly ash, slag cement, or silica fume, and for the both cases, the aggregates were stone chips and sand.
Now let's talk about the concrete mix design. We have two types of scenario. Number one is base case scenario and number two is alternative case scenario. In our base case scenario, the total volume of concrete is 1 meter cube. As it is mentioned in the rules, the water cement content is 0.4. From various literature review, we have chosen fine aggregate to total aggregate ratio as 0.44. The air content is taken as 2% for Bangladesh. The specific gravity of coarse aggregate and fine aggregate and the aggregate type, minimum slab, maximum aggregate size can be seen in the slide very clearly. We have chosen stone chips for coarse aggregate and sand for fine aggregate. Now coming to the alternative case scenario. In an alternative case scenario, we have added some supplementary cementitious materials such as fly ash, slag cement, and silica film with our cement content. The specific gravity and the percentage replacement of the supplementary cementitious material was taken from various literature review. The total replacement is 40%, and the total cement content is 387.870 kg per meter cube. If you see, both for the base case scenario and alternative case scenario, the cementitious material was same as 387.870 kg per meter cube. The total volume of base case scenario and alternative case scenario was same as 1 meter cube of concrete.
Now let us look at the service life of the mix. We have calculated the service life of the concrete mixture using the Life 365 software, which was provided to us in the competition, and where we have inputted all the data and we have seen the result like this. The service life score was 4.421 for our case. We have calculated this from the graph, and the corresponding BCS and ACS mixtures, the service life was respectively 11.9 and 52.4 years.
Simplified life cycle assessment, or also known as LCA, is a scientific framework for calculating and analyzing the environmental consequences of a product's life cycle. We have shown a system boundary for the LCA of the concrete. Here we can see the material production part, the transportation part, the construction part, the use, and the end of life. Also the inputs, process, and the outputs. There are some certain factors that affect the LCA of a concrete. Global warming, carcinogenic, ozone depletion, ecotoxicity, and fossil fuel depletion. We can improve this factor affecting LCA in the alternative case scenario of our Ecoconcrete. Here we can see some certain impact categories we have already discussed, and the base case scenario and the alternative case scenario results. We have seen in the case of global warming, we have improved 30.7% potential environmental impact reduction in case of global warming. In the carcinogenic section, we have seen in our alternative case scenario, we have improved 18.9%. In the ozone depletion section, we see that we have improved 26.9% over our base case scenario. In the ecotoxicity section, we have seen our alternative case scenario has 19.5% potential environmental impact reduction. In the fossil fuel depletion section, we see that our alternative case scenario has 28.8% improvement over the base case scenario in case of potential environmental impact reduction. So our overall average result is 24.9%, which is pretty good considering we have improved and considered all the selected impact categories in our Ecoconcrete.
In the final part, which is called conclusion. In this part, we will talk about environmental impact reduction, sustainability of concrete, eco-friendly mix design, life cycle assessment, and betterment of service life. Now, the main activity means the sustainable development which meets the necessity of this without compromising the power of future generations to satisfy their own needs. The concrete industry is no exception in this role. Within the negative impact on this environment, the cement production is extremely energy intensive. Cement is among the poor contributor to carbon dioxide within the atmosphere. The Ecoconcrete eliminates the negative impacts of the cement industry, minimizing the environmental impacts. Therefore, we must always attempt to reduce the amount of concrete utilized in building to exchange the utmost amount cement as possible as supplementary cementitious materials, especially those that are byproducts of business processes like carbon dioxide and other environmental aspects depends on mix design and material uses. Found that the focus is on known benefits and the limitation of a separate manufactured and recycled aggregate. Betterment of service life. We can say that among all these things we have been talking about, this together make the service life of cement, and which is very much appreciable and which is very much environmental friendly. Thanks for your patience and thank you everyone.